After our first day of analysis of the wheel and axle data, we looked at how position and clock reading were related and got this graph. And then we tried to linearize that by looking at how position and clock reading squared were related, and we got this graph. We found, however, that we might be able to learn more about the motion if we were to make a velocity versus clock reading graph. And in class, we learned a technique for doing that. I want to show you how to do it in LoggerPro. And much like adding this calculated column of clock reading squared, we're going to add the other columns that were suggested, which include change in clock reading, change in position, average velocity, and middle time. So we're going to go to the data menu. We're going to select new calculated column. We're going to call this column the change in. So we have Greek upper letters including delta. So we're going to say the change in clock reading, the symbol for which is going to be delta t. Units will be seconds since clock reading was in seconds. And now we've got to put in an expression for the change in clock reading. Well, over here we have something that says functions, and one of the functions is delta. If we put in delta, the variable clock reading, and then hit done, it will create a column for the change in clock reading. Notice that each of these changes in clock readings are 1 second, because the change from 0 to 1 second is 1 second, from 1 second to 2 seconds is 1 second, and so on. Unlike the way you were shown to do it, these change in clock reading values, they skip a row, and so this change is between this clock reading and this clock reading. This change is between these two. Ideally, these would be right on the line in between them. LoggerPro doesn't have the facility to do that. If we double click on this, we can also go to options, and as we've done so many times before, change this to black and an empty circle. And I would say go with a displayed precision of probably 1, like we've done on the others. So now we have the change in clock reading column. We're also going to want to have a change in position column. So we're going to add new calculated column, and we're just going to go through the same thing. So this is going to be the change in position, short name, which is the symbol for it, delta x. Units are going to be meters. Expression is going to be delta, and this time we're going to do change in position. And there we have it. We've got to do our other little business with the color and the circle. Now we have the change in position column. If we want to calculate the average velocity between successive data points, we simply are going to divide the change in position for that interval by the change in clock reading for that interval, which simply means dividing the values in this column by the values in this column. So we're going to make a new calculated column. This time we're going to call this average velocity, symbol for which is V with a bar and an arrow, and once again we don't have any of those symbols we can put on there. The units are going to be meters per second. The expression for the average velocity is going to be that it's equal to the change in position. We're going to use a slash for divided by, and then we're going to divide that by the change in clock reading. Hit done, and now the velocity column has been created. We can go to empty circle and our default color of black. And we have one more column. Now what we did was to calculate the average velocities between successive data points. But we also learned that those average velocities represent the instantaneous velocities at the middle of the intervals for which they are the average. So for the interval from 0 to 1 second, the average velocity, which turns out to be 5 meters per second, is the instantaneous velocity at the middle of this interval, which is 0.5 seconds. The average velocity from a clock reading of 1 to a clock reading of 2 turns out to be 15 centimeters divided by 1 second, or an average velocity of 15 meters per second. And that's the instantaneous velocity halfway between a clock reading of 1 and 2. So we're going to want to make a T-mid column, because T-mid represents the clock reading at which the average velocity is an instantaneous velocity. So we're going to go one more time to data, new calculated column. This is going to be called, I'm going to call this the middle time. The short name for that is going to be T-mid, and I can't really do subscripts for letters, so I'm just going to call it T-mid like that. That's going to be measured in seconds. Now this one you're going to maybe want to write down to remember, because it's not obvious how you do this calculation. What I'm going to do is to make this by taking the clock reading, and then I'm going to subtract from it half of, so I'm going to say 0.5 times the change in clock reading. You might think it would work for plus, but the fact that it moves this down one row means that this number has to be a minus. So you calculate the middle time by taking the clock reading minus half of the change in clock reading. So it's going to take 1 second as a clock reading minus half of the change of 1 second, and it's going to give us 0.5 seconds for that. I might as well go to my options and get my colors, my displayed precision, and my point protectors right. And then when I hit done, there I have it. I have my middle time column. We were testing to see how velocity changed with respect to clock reading, so this might be a good time for us to add a new graph. So I'm not sure what that's supposed to be, so I'm going to get rid of it. I already made a position clock reading graph. I made a position clock reading squared graph. Now I'm going to make a velocity versus average velocity versus mid-time graph. So on this page, I'm going to insert a graph. As I've done every other time, I'll make that graph considerably larger. It really doesn't know what I want to graph, so it guessed wrong. What I want on this axis is the average velocity, and I want to plot that at the time at which this velocity is an instantaneous velocity, which is at what I've called the middle time. And now you see I get a nice linear graph that appears to go through the origin. I can do a linear fit on that, and I see that the slope of this graph is 10 meters per second per second. You might want to compare that to the slope of the corresponding position versus clock reading squared graph, and you find that that slope is 5 meters per second squared. Velocity versus time graph for the same set of data, a slope of 10 meters per second. Position versus clock reading squared graph for that same set of data, 5 meters per second squared. What do you think that might mean? Now once you've done this for one data set, it might make sense to do the same thing for the other incline. And so in this case, and I showed this on another video, but I wanted to show it for a larger data set because it's kind of slick how it's going to do a lot of work for you. We're going to go here and say new data set. We're going to call this, we're going to call this wheel and axle high incline. Get rid of the 2. Later on I'm going to go and change all of these to black, but once again it gave me all of the same columns here that I had over here. I didn't have to type in any of the headings, units, and I don't have to define what each of those columns is worth, because it's going to assume that these are calculated in the same way that these are calculated. So my clock readings are going to go from 0 to 6 in increments of 1. And all of a sudden, all of the columns that did calculations based only on the clock reading got populated. My positions, and I did this again on the earlier video, were 0, 10, 40, 90, 160, 125, excuse me, 250, and 360 meters respectively. And as I added in these positions, the columns that depended on the position, which were the displacement column, change in position column, and the average velocity column, automatically got filled in. I now go to page 2, and I want to have the position clock reading data for the other one. I go to More, select, I have all those columns for the low incline. I click on this. I now have all those options for the high incline. And so I want to plot position versus clock reading squared for the high incline. And there it is. And then, as I said before, we can do the curve fit for that incline. We're going to choose power, try fit. Looks like it fits pretty well. And there we have. Remember, we're going to want to change the point protectors to an open circle. And that can be done over here by selecting this column here. And when I go over here and change that to an empty circle, change that to, say, black, then we can come back to the graph, and now I've got empty circles on that other one. I might want to do the same thing for the position versus clock reading squared graph. So I add in, select the position column, go down to high incline, select position, and now I can do a linear fit for the high incline. There we have it. We've already seen that on a previous video, but now we're going to do the same thing for the velocity versus clock reading graph. You'll notice I messed up here and I didn't tell it what to call this graph, so I'm going to go back and correct that now. It's going to be a velocity versus clock reading graph. That's the title. But notice the velocity is the average velocity, but it is the instantaneous velocity if the clock reading we choose is the middle time, which is what we did. Now we are going to want to add the data for the high incline. So we've got wheel and axle low incline, and average velocity is selected. Come down here, open the high incline, scroll down, and we can put the average velocity for the high incline. And then we can do a linear fit for that. High incline. And there you have it. Both velocity versus clock reading graphs and one set of axes using the average velocity middle time method. We have the position versus clock reading squared graph for both the high and the low incline. And the position versus clock reading graph. I don't know why it's doing that. For some reason it's moving my whole graph around. Let me just move this back over here where I wanted it to be. And there we have our position versus clock reading graph. We have our data sets. Again, I would go through and change these to black because especially these light colors are not going to print very well on a black and white printer. And then you'll also want to change your point protector so you're always getting the open circles. That should do it. Explore and have fun.